Today we're working on factoring a trinomial. And when we say trinomial, tri meaning 3. So you are going to have a guy who's squared. You're going to have a guy right there in the middle. We call it a regular guy. And then we're going to have some number guy. Now as we go through this, what we are trying to remember is that this would be considered our A term, this would be considered our B term, and this would be considered our C term. And how we factor a trinomial is what we're looking for. We're looking for two numbers that multiply to be our C term. And also those exact same two numbers have to add or subtract to be our B term. So we're going to look for factors. So remember from last section that we are going to hit our y equals button on our calculator, and from there we're going to look at our constant or our number, and we're going to divide it by x. This will allow us to figure out what our factors are. When you hit your second key and then your table, you're going to see that our table pops up. And what we're looking for is we're looking for two numbers that multiply to be 10. So we have options of 1 and 10, 2 and 5, or 5 and 2, which those are the exact same factors, but somehow get to be -3 when we combine them. So if we use 1 and 10, there's no way that we're going to get a 3 from 1 and 10. We would either add them and make an 11, or we'd subtract and get 9, or even -9. So our options have to be 5 and 2. That's the only way for us to get a 3. So when we are factoring a trinomial, you will always have two sets of parentheses that get set up. If we're looking at an x squared, the only way to get an x squared is to multiply x times x. From there, we know that 5 and 2 are our options to make 10. So we put our 5 and 2 in the other part of the factoring. We want 3 to be negative, therefore our larger number is the number that's negative. We pay attention to the final sign that is negative. The only way to have two numbers multiply to be together to get a negative number is if one is positive and one is negative. And we can go ahead and think, is -5 plus a +2 -3? Yes, it is. Therefore, we know that that is what x squared minus 3x minus 10 factors into. So let's practice a couple more. Let's look at 8. If you do 8 divided by x in your calculator and then look at your table, you're going to see that you've got 1 and 8 as a factoring option, or 2 and 4. 4 and 2 is also going to be listed, but it's the same idea. So of these two options, which one is going to get us a 6 somehow? Hopefully in your head you recognize that 2 and 4 is going to get us a 6. So we set up our two sets of parentheses. The only way to get an x squared is to have an x and an x. And we want a -6, but a +8. The only way to get a positive number at the end when you're multiplying those two numbers is to either have two positives or two negatives. Because the 6 is negative, we know that both of my signs have to be negative. And is -4 and -2 a -6? Yes, it is. Looking at our next example, we again can set up our parentheses. Do 24 divided by x in your calculator to figure out all your factors. You're going to see that you've got 1 and 24, 2 and 12, 3 and 8, 4, 6, and that's it. So looking through this list of 4 different options, which one of them can get us a 2 somehow? Hopefully, again, you recognize 4 and 6 can get us a 2. So we split apart x squared into x and x. we recognize that this is a negative number. The only way to get a negative number when you're multiplying two numbers together is there to be a positive and a negative. And we know that we want this 2 to be positive. Therefore, our larger number has to be the positive number. And if you're ever questioning whether you did it right, don't forget about your foiling technique, where you can check your work by distributing back in to make sure that you end with exactly with what you started with. Now again, this is a trinomial because it has 3 terms. And what really scares people is when we throw that extra variable on the end. Your factoring does not change. Your process does not change. The only thing we have to look for first is 1, always look for your GCF. And 2, we recognize that because a squared is in our beginning, we've got an a in the beginning of each of our factors. And because b is right here on the end, we're going to have a b at the end of each of our factors. We're still looking for all the factors of 20 that multiply to be a negative 1. So we look at our factors of 20, 1 and 20, 2 and 10, 4 and 5. Which one of those 3 options is going to get you a 1? Hopefully you recognize 4 and 5. Again, because this last term is negative, the only way to get a negative final term is if you have a positive and a negative number being multiplied together. Because this middle term is negative, we want our larger of the 2 numbers to be negative. And looking at this example, always the very first thing that you need to look for is you need to look for a GCF. I see that I have 4, 12, 72. I know that 4 can go into both of those, so I'm going to pull out a 4 as a GCF. I see that I have an x here, an x here, and an x here, so I know that x is a GCF. I see that I have 3 y's, 2 y's, and 1 y. I know I can take out at least 1 y. That will leave me with y squared plus 3y minus 18. So we leave this GCF. That doesn't get touched again, but we recognize that we have a trinomial now. So I separate this into my 2 binomials, and I think about my factors of 18. 1 and 18, 2 and 9, or 3 and 6. Which one of those options is going to get us a 3? Hopefully you recognize the 3 and the 6. So we split apart our y squared into y and y. Again, we recognize that there is a negative sign out there at the end, so the only way to do that is to have a plus minus. Because this 3 is positive, our larger number has to be positive. Once we've pulled out our GCF and factored correctly, we know that that's our final solution. And last but not least, we recognize that we have an x to the 4th, an x cubed, and an x squared. I don't see any coefficients that are the same, but I do see that I can pull out an x squared from each of those terms, leaving me with an x squared plus 2x plus 5. So I think about my factors of 5, 1 and 5. Is there any way for me to get a 2 from either adding or subtracting 5 together somehow? The answer is no. If I added them, I'd get a 6. If I subtracted them, I would get either a positive 4 or a negative 4, none of which gets us a 2. Therefore, this trinomial is what we call prime. The trinomial is we were able to actually factor the original problem because we could pull out the GCF. So my final answer in this case is x squared times x squared plus 2x plus 5. That is the only thing that we could do, was to factor out the GCF.